let's move. And a first commentary about this is that you can find right now the just go to Google and go to Ethereum 2.0 launch, but and just click in the first entry, and you can find here exactly what is a validator, what is a deposit contract, and so far how to stake in your Ethereum for have rewards for be a validator. So it's a guide, and you only got to get started, and you have different introduction steps here in the phase 0, the spec that we are talking about right now. And just to follow the rules of this overview, and in 10 steps you can finally staking your Ethereum. So just put continue for get the knowledge. You need the 32 Ethereum per validator, and you have a step. There is some responsibilities that is actually a trade-off of the proof of stake, that are the penalties. There is some risks, that are the slashing risks. That is the thing that we're talking about right now. And so far, just follow the rules and choose your setup node, then continue. We are in Golan, so the prince is the client of Golan, and put the validators that you want. You need this kind of cost on Ethereum, because one validator is actually 32 Ethereum. So choose your current operating and just follow the instructions. But this video is not about that. It's only a review that it's interesting you can do with this Ethereum 2.0. So let's move to the spec. And we're talking about Ethereum 2.0 spec in the side of the validator. So I have a problem with my voice, so it sounds very artificial. Maybe if I adjust a little bit my micro, I can have better performance. Okay, I think it's a little bit good, but anyway, so this problem is calling not in a stake. That means that you have a blockchain. Okay, you have one block here, you have another block here, another block here. So this is connected with a chain. And with imagination, you have here a blockchain. In this side, we have a miner, And this miner decide how what is the next block to put in the chain. So you only chain in the proof of stake the miner for this new guy called invalidator. So this is the miner, and we chain for the validator. So this miner validator, or validator only, decide what is the next block. Imagine that this validator needs to decide with this block and this block, but this block is very different with the other block. We can say that this block is a malicious block. So this miner validator decides and put this. But when the hash come in and want to integrate this in this blockchain, the miner and the longest chain don't decide that this is a correct block. So it's deprecate and put the correct block. And the correct block is the block that have the previous hash. So it's a cheesy interpretation of this. But in this Ethereum 2.0 specs, we have a different chain. That is a shard chain that actually means that you can have a better distribution for these chains. You can have a shard in one direction, you can have other shard in another direction. That means that you have different distribution for this data, and actually you only need to validate the principal root. So this is how work in a silly introduction works the Ethereum 1.0, but in the Ethereum 2.0 you have different chains that are calling shard chains. That actually it's pretty similar. So let's draw with this. So you have more chains here. And more chains here. So it's fantastic. You have more chains here that actually are connecting, but you have more entropy here. So you need to validate not only one chain, a principal chain. You need to validate different chains here. So it's challenging because remember that the immutability of the blockchain is the principal spec for the blockchain specification. So you have different blocks here. You can actually call in this shard one, and you actually call shard number n. That means that you can have any number of shards here. So, but you have a principal chain here. That actually in the Ethereum 2.0 they call him beacon because it's a beacon state. And the specification of beacon means that handled the verification of the other shards that actually are other chains. So you actually have this principal chain that actually needs to verify here. So you can see that this miner validator is pretty confused here because first needs to verify and validate this beacon chain. That is the principal chain and actually the shard chain. So the miner validator needs to put new tricky rules for validate all the state. That includes the shard chains, the shard end chains, and the principal beacon chain. And the elegant solution for this is calling attestations. So the beacon chain start to make attestations in the different shard chains, and you have a better distribution in the data. So it's a silly picture here, but works pretty fine for understand this. So okay, that it's the Ethereum 2.0 spec for handle better distribution in these shard chains. But start to have more problems here. Okay, works in the picture, but in the reality with the practice in the code, you need to make a lot of things in the code for don't have a buggy interpretation of this. So let's to find a simulation for make this more interesting. So just go to Google and Google Ethereum 2.0 Python simulation. Or Ethereum 2.0 simulation, I can't remember exactly where's this simulation for the beacon with these chains for distributing the data. Okay. So let's download this. Okay. We have a better interpretation on this, and I think this is the validation. We can actually okay, we have here the validation and start the beacon chain and the shard chains. So these start growing with the time. And you need to validate all the shard with the beacon chain principle. So the first line that you have see here, that is the blue arrow, is calling crosslinks and are beacon blocks and shard blocks connecting. So start and start to appear one block yellow that is calling the finalized block, and that's mean that is start to validate the beacon block. But you can see also that another yellow appears. That means that the shard chain start to validate. So these crosslinks that are a number of attestations start to validate all the state. So you can see this new spec for building this new blockchain that actually increase the velocity of the Ethereum protocol specification. So okay, this is fine, but if you're looking more in a deeper way and research what kind of problems have here, is actually the forks. Actually, the forks is a network partition. how to figure out that this beacon chain actually never fork or make a properly attestation. So that's its challenging stuff, and let's move. And this problem calling that as nothing at stake. That actually means it's called nothing at stake. That actually means that. Oh, sorry, my open board crash. I think because it's bugging. Okay. It's crashing. Sorry by that. Okay. You have. Okay, it's crashing and crashing. Okay, I need to change for another application because it's buggy open board. It's not working like I want. Okay, it's calling nothing at stake. And actually it's a problem for validate all the things in the chain. So let's put an example. We have this chain, and remember that you have a guy that decide what is the next block for this and validate all the state in the blockchain. So you have here this stuff with a hash here connecting the blocks. So the problem that you have different chains here that actually are shard chains. So the validators decide what is the next block with the stake that they have. The stake is the number of Ethereum of ethers that they have in his wallet. So the 99 stake problem is that actually one validator that actually acts malicious, that is represented with this start to validate for create double spend issues that actually is having more or earn more ether for spend the things that you have. That actually is a malicious issue because this validator is a malicious validator and decide that this shard needs this kind of blocks that actually are tricky, malicious blocks that don't work for the shard chain. So you actually don't nothing spend in this stake because it's a malicious. So the beacon that you have make that are making the attestations like in the simulation that start the attestations that are actually these blue arrows. make a fork of this. That means that this shard chain is not validate, and start to make a fork. So these are a research theory problem that actually makes sense in practice, because you can prove this in practice, making a code and make a shard validator malicious. But actually, Ethereum 2.0 spec tried to fix this, nothing on a stake problem. So these are research, and this is the thing that we are talking about. And let's see the code for the solution of this. So let's move to Goland. And create new project for make this scratch. Let's create a new Go file, and let's call in chain data. And let's start the code. So let's go to enter presentation mode. We need another font size, maybe 25 it's okay. Let's reset this. Okay, so let's create this chain data that actually proves the data that we have in the shard chain, and it's one that is a one method that you can use for actually avoid the not enough stake problem and variants of this attack. That actually is the long attack. So we need the package that they call it the beacon client. We need to import something here. We need a context, time, we need some libraries. That it's proto buff types for buffers. We need more libraries for handle this. some APIs here. More libraries. Above parameters, we need more libraries about so let's start coding this chain that data for avoid this kind of not in stake problems. So we need the status of this that they call in polling interval. And we have the parameters of this beacon config that actually it's the principal chain. Then we need to create the chain head request, the latest chain head from beacon nodes, VM, any kind of method. So actually that means that you need to handle the chain head request that you have in this. So you need to handle the request in the chain head of the other charge chains. So this is for have a chain data and avoid the problem that we are talking about, that is the not in out stake. So that is the first issue that you need to handle. And in the site, in the protocol specification, you have a pseudocode of the slasher validator that actually is a validator plus epoch and the boolean. So basically it needs to check a validator is a slashable. A slashable means it's have penalty for have a malicious activity. So it's like the police guy that decide this is good, this is bad for the protocol. So in the other side you have another spec that is this is slashable attestation data that need two parameters in the spec, that is the attestation data will be a boolean of this, and basically is check if data 1 and data 2 are slashable according to the rules of the protocol. So you have two spec here. So this will be a function of this service and will be for the chain head. You need the context of this. So, and start with the argument of this. Then basically you need to trace the beacon client and make a return for retry the chain head. So that is very complex because you need the context of this, a span of this for trace. That actually needs the context. The beacon client chain hit and the first span end of this. So debug these errors that you can have for handle this request of the chain head. We need things of the library, and it's the p types that we import here. And debug this error. So basically we make the first function for handle requests for the chain head for any kind of beacon node via any kind of method for distributed systems that actually they use the RPC move. They use the method calling gRPC remote procedure call that actually is using in distributed system. And basically the thing that this stuff do is handle a better distribution of the data and connect different kind of arguments in the code with another arguments. So the next thing will be the interesting thing for validate the roots request and fetch from memory the beacon chain genesis and validate to root via the same method that is the remote procedure call. So let's create the function. and it's the Genesis validator root, the name of this. That actually have a context. It's the same of the chain head. It's the same parameter for this. You can see here that have the same parameter, because in the spec we have to check if this kind of the data are slashable according to the rules, and check if the validator is slashable. So in the other side, in the slash client, you need to make the service for make a validator root for all the requests that you have in the simulation. That actually it's this. You need to handle all the requests for the shard chains. Remember, you have the beacon chain here and the shard chains in the other. So let's move to see how to make the validator root for this. So you need to buy the error of this and start with a span thing that trace actually the beacon client and the Genesis validator root. So you can see actually it's the same argument for handle the request over the chain head. So let's move to see what kind of argument have, and actually it's pretty similar because it's the same method. We can see that the method of this is remove processor call. That we can see that it's from distributed systems. So let's start with the statements. So if the Genesis validator we need to check this, that is a nil, for handle the other things. you can see that actually it's pretty similar with the chain head context for handle the requests. So let's see simulation for make sense. So actually this function is to trying to put the data in the chain and handle all the things that happen in this entropy validation. So let's debug this statement for the other thing that could happen, calling others wise, and it's errors of this. That it could not retry Genesis data. And we can see that we have here the problem that we're talking in the beginning, that is calling nothing as stake, that this block don't have data for serialize correctly. So let's finish the function for this. And the validation of the root. Return the VS Genesis validator. We finish for handled the request of handle the request from memory of the beacon chain Genesis. So remember that we have here the simulation for make sense, and I'm losing this because it's pretty confusing. So we have here the Genesis for the beacon chain and the Genesis from the shard chain. So let's debug the request for this Genesis validator root and handle better implementation of validate all the chains that we have here. So let's finish this, and will be the pull the beacon every seen status pulling interval until the node is no longer syncing. So this will handle all the pulls that the beacon chain start to do when all the shard chains start to growing with the beacon chain. So let's create that last function for this chain data stuff. So basically we have here the stuff for handled the data from the node, and actually the otherwise is no longer syncing. that means that it's not working good. So let's create a function that actually will have the same parameters, the service of this, because remember we are in the side of the client. And then we change different parameters of this. This node will be the same context, and obviously the statements and their will be different because we're not taking the genesis of this, that actually is the block 0 in the chain, and we are not taking the chain head, that is retrieve the chain head for the beacon client. So it's pretty confused, but makes sense when you work in shared chains. So the next is service, and this will be the query sync status. The name of this that have this context and start the statements. The first one will be one status of this and the errors of this. For the side of the node client, and the things start to be pretty weird in this state. And let's debug this. Could not fetch sync status, so this will be otherwise of this that not working properly. So we need a statement for brute for this. Beacon node, it's fully signed set. Starting slashing detection. So basically we have here the scene status trying to pull the beacon node until the node is no longer signed. So we have the otherwise things that this status not fetch very good, and this slashing detection starting. So this will be the brute force of this argument. So the next thing will be pretty confused like the first. And we need to return this thing because it's a continuous sync status. So we need to queue this. So we need a ticker for time, new ticker, sync interval. Debug this. And finish with a little loop for select the things that we need. That will be the first case of this. Actually will be a ticker C status. Let's debug all the cases of this. Debug the errors that we have here. And will be the first error could not fetch. Again, this sync status. So the next statement will be for find a null and the status signs. So basically we are looking for the different variants of this statement. Return the method, and finally it will be the case for the book the context and return all this loop for handle the sync status. So need to create evidence of this or log of this, waiting for beacon node to be fully signed. And the done version. So finish with this. Context closet existing routine. Return this, and we finish with this. So actually we can find here for different kind of research question. The first one, how to handle a shard chain with a different kind of topology, figuring out how to expand the shard chains and make his own activity in the beacon state, and actually looking for brute force the fortune rule for handled the nothing on stake problem. So there is a large questions here for this. So this is all for today, and so far we saw different things here about the Genesis validator root for the method of the remote processor call. Actually, we saw how to handle the requests for the chain head in the implementation and other things here. So see you in the next video, and I hope that you can find here very interesting this for Richard question, and actually for building your own blockchain with the characteristics that you're looking for. So have a good night and see you.